Okay, question 14. Consider the two inequalities. So we have absolute value of x plus 5 less than absolute value of x plus 11. And we have absolute value of x plus 11 less than absolute value of x plus 1. Fine, so two absolute value inequalities, which we have in A-level as well. Which one of the following is correct? Okay, so we need the intersection of these two inequalities, right? So let's solve them one by one. So, I mean, for me, instead of doing algebra, I actually prefer drawing graphs. Yeah, I think graphs are much more helpful. So let's just look at the first one first. Okay, so x plus 5, right? So absolute value of x plus 5, this is just a shift to the left by 5. Yeah, the transformation is a shift to the left by 5, so I have this, negative 5. Okay, how about x plus 11? Well, for x plus 11, it's a shift to the left by 11, so it's somewhere here, like this. Yeah, they have the same gradient. Yeah, they have the same gradient. Okay, so therefore, you're sure that the intersection here is negative 8, right? Because they have the same gradient. So no doubt they intersect in the middle. Yeah. Okay, so when is the x plus 5 graph smaller than the x plus 11 graph? Well, it's between here, right? Any x value which is greater than negative 8, that's true. Right? Okay, now I'm also going to put the x plus 1 graph on here. So my x plus 1 graph, so that's negative 1. It probably looks something like this. Okay, so now compare the x plus 1 graph with the x plus 11 graph. Okay, and of course the intersection here. Intersection here would be negative 6. Yeah, because again, you take the average of the two x roots. Yeah. Okay, so when is this applicable? This is applicable when, this time this way, right? The other way. When any value x is less than negative 6. Yeah, then the x plus 1 graph is above the x plus 11 graph. Yeah. Okay, good. So the intersection of this would be negative 8 and negative 6. Yeah, you're bounded between, so therefore, the interval is length 2. Yeah, so I think it should be D